Hello and welcome to the design part of this project. I'm Sebastiao's successor for this project and I will take over for designing. First of all, I would like to explain a bit about the general gameplay. Because this flipper has a virtual component, a lot of features and effects can be added which are usually not possible in a normal pinball machine. And this enables us to split our flipper into different stages where the player has to defeat different enemies, which leads to an epic boss fight at the very last stage. After completion of each stage, an upper part of the playing field will be unlocked, which adds new features, new objects, and also additional space to play on. As I already said, this was last semester's collaboration project, so a lot of features and mechanics were already there. So my part in this project will be to look at already existing mechanics and features like player assisting objects, the enemies, a shop feature, and the story, and put everything together into a playable, balanced, and fun layout.
Hello everyone, I am Sebastian Herena, and for this project I will be part of the art stuff as I did last semester. As you may know, last semester I was in charge of the character development as well as the UI design. So a good place to start is the feedback that I get from Bjorn last semester, where he said that I basically could have done a better job. So from that I started making some research about how to make a better characters, and I found this book, Creative Character Design from Brian Tillman, where he states some steps to have a good characters. So one of those is the background story. So for that is definitely a topic that we lack last semester. Basically our characters were really random, and now after an ideation session with my colleague Kevin, we finally have a really good background story that we can justify the appearance, and not only the appearance but any other elements of the characters, as well as we link this background story with the metamorphosis concept. So another thing that we're going to work on is to have a balance between the real objects and the digital objects in this project. So we will work even more in the details of the real 3D printed characters, as well as the many experimentation phases with the digital appearance of the screen, like how it behave with the real objects beneath, and we will find like a balance between them, between both. Yeah, we will have something good for the end. We will try to.
Hello, I'm Kevin and the second artist for this project. I'd like to highlight some of our artistic limitations. We can divide our pinball box into 3 layers with different characteristics. I'll begin with the bottom layer, which is the ground of the box. Basically, the ground is just a soft white light source, and for what we do, it is comparable to watching straight at the glass surface of an overhead projector. Some of us might still know from school. We can put a static colored foil on top of it, but here we need to keep in mind that the light that will shine through this foil will be the key light source for the other 2 layers, which I will explain in a few seconds. Knowing that especially the 3rd layer, the actual TV screen, mixes its colors with those of the foil, we can already leave out some white spots. The only spots we want to leave out for now are the bottom corners, since we want to display our menu and HUD there. The 2nd layer consists of the actual 3D prints that we will paint by hand. We thought that we can avoid the step of doing the UV layout for all the prints, but it actually gives us more flexibility to paint the 3D models first digitally and see them combined with the rest of the box beforehand. Here we must still figure out a fitting color scheme in the next few days. For the last layer, the TV screen, we have a special limitation. Everything we display on it will be seen like through the Photoshop blending mode Multiply, which means that everything that is pure white is completely transparent, and everything that is black will be actually displayed as black, but allows no longer to see through the screen. Instead of trying to avoid wild color mixing with the layers beneath it, we now try to use this behavior of the screen to our advantage and try to create a unique visual style with it. Like I already explained for the first layer, only when the bottom layer is everything except white, the colors on the screen will start to multiply with them. This is why we try to keep all the moving objects either monochromatic or leave them completely desaturated. We still have to figure out a version that is visually the most pleasing, but we are on a good way since we are finally aware of the artistic limitations we are facing.
As for the game that is running on the machine, we will continue using Godot as our engine of choice, and we'll continue programming in GDScript, which is Godot's own scripting language. It's a bit similar to Python. So far, I have been paying a lot of attention to making the game modular with little to no dependence between game objects so that we can easily iterate on the design, which I'll continue to do because I think it's important. So far we haven't taken much advantage of this, and it really shows in how the game plays. It's kind of cluttered. We haven't really tested it much, haven't really thought about which game mechanics actually make sense, and kind of just threw all of it in there. So after I'm done with the code-based cleanup, fixing some of the bugs that were still in the game, making the code easier to build on top of, I'll hand it over to Tamina so that she can come up with a good playing field layout and work out what deserves to stay in the game and what doesn't. And I myself will actually move away from the game for a bit and help out Marco with the hardware stuff, because last semester I made the mistake of just tunnel visioning the game.
So for the programming of the hardware part, the box was left with a lot of problems. For instance, the buttons and the plunger didn't work properly because of the way we were communicating between the Arduino and the NG engine. It was done via a serial port, and the elements were interfering with each other. I've already fixed this problem by buying an Arduino Leonardo, which is a very similar microcontroller as the Arduino Uno, but has the additional feature of emulating a keyboard presses. So I can use that for the buttons and leave the serial port just for the plunger sensor without any interference then. Another big issue of the feature box was the fact that the illusion of hitting the real objects with a virtual ball breaks when the player is moving around, because it's not aligned anymore with the projection in the engine. So what we thought about was head tracking the player and move the camera in the engine according to the position of the player. But I tried to implement that with Archer the last few hours of the before the showcase, and it obviously didn't work. This time I want to tackle the problem in a more scientific and mathematical way, calculating the right parameters and finding the right equations beforehand, instead of guessing like we did last time. Lastly, we wanted to implement real flippers. Wrong flippers, sorry. These flippers, yeah. We wanted to have real ones, but I didn't come to that. The problem here is at the end just finding the right motors for cheap, as real pinball machine solenoids are quite expensive. Other than that, I'm excited about finishing this project, and with a more clear and focused mindset.